Hello friends and welcome to the last lesson of Unit 3 where we'll be trying to do some work in Microsoft Azure ML. As we had been discussing in lesson 3, 4, 5 and 6. So let us take some of the exercises which I've given you during these lessons and try to do that today. You might have done that and some of the things you might be finding some problems. So let's do that collectively today, and we call this as our case study. So today we are going to discuss and work purely on Azure ML, and we'll take up the same credit card examples, the two homeworks which I've given. So I'll be taking up those as promised. So firstly, what we have done so far in Azure ML was taking this credit card data set where we have segregated the data for high school and masters using the SQL queries. And we had seen the age for high school has been 40.3, and there are around 4,917 records with us who have high school education, and the limit balance on the average is the mean is 1,26,550. When we talk about masters, it is 34.2, number of observations 10,585, and the mean limit balance which has come out as 2,12,956. So what we have done so far is like a statement, is there any evidence to support the following, that the average limit balance for customers with master's degree is more than 2,10,000. So we have done that. We used one tail GT for that, and later we used one tail LT, which we'll do today because that was one of the homeworks. So we did that for 2,10,000 where we used one tail GT. So, and then I gave you this question which is homework 1, and let us look at that. So what we had seen so far is how to build the hypothesis. So you have a null hypothesis in case of the limit balance. So we put it as limit null hypothesis average limit balance less than equal to 2,10,000, which is what we are saying. And then we had the alternate hypothesis, which was average limit balance is more than 2,10,000. So we calculated the p-value, we checked whether that is less than the significant value or more than the significant value, which was 5%. So that is what we have done so far. So now let us do the homework 1, where I asked you to work on this, wherein what you need to do is the null hypothesis. This is on age, that the age for the master's data set is greater than equal to 34.3. Alternate hypothesis which we would like to prove is age is less than 34.3. And this is an example for one tail LT. Rest everything goes as we have done for the limit balance. So let's do this. So what we do, we go to Azure ML, log in there. Either we pick it from the save data set, the credit card set, and then we apply the SQL transaction for the masters and for the high school. Then we compute the linear correlation. Right now, in this case, we do it for masters only because this age 34.3 would like to check only for masters. So under the SQL transformation, we compute the linear correlation, and that we need to take to the side. We don't require that. So what we do is we bring test hypothesis and we bring it below the SQL query here. Once we have done that, after that we run it and then we right click. One of the things which we did here is one tail LT, because what you put what you want to check under the hypothesis is what you want to prove, that is the alternate hypothesis. So that is why I use one tail LT. So this is the example for one tail LT. Rest everything remains the same. So we get a p-value which is 0.198. and then you look at the hypothesis visualization. So it is false, so you reject the null hypothesis. So here comes your p-value is sorry, p-value is 0.198, which is greater than the 5% significance level. So what we do, it is probability is high to get that age there, that is 34.3. So that means we do not reject the null hypothesis. So we take it that yes, the age is greater than equal to 34.3, and this is not a statistical noise. Now the homework 2, which is on A/B testing, which some of you were not able to do. So let us do that jointly, and let us work in Azure ML to work on this example. So this was the problem I gave you. So again, the data for high school and masters from the credit card data set. So here, when we talk about A/B testing, that is between two data sets, between two variables. So here I am taking average limit balance. So one is the data set which is for masters, another is for high school. So what I would like to the statement, whether that is true or not, which we are giving here, is average limit balance for masters is $75,000 more than the high school. So if you look, 1,26,520 is the limit balance mean for high school, and 2,12,956 is the average limit balance for masters. So if I see the difference, yes, it is looking as more than 75,000. So whether that is a statistical noise or whether I can vouch for this statement. So that is what we need to do. So what I gave you the hint as that you go to Azure ML, you put the SQL queries, but here you name the columns, and after that you add the columns and you get one data set out of both masters and high school, and then you have unpaired samples of one tail LT test, and then you look at p-value and you conclude. Now let us do it and how we do it. So the first thing is that I go to my SQL query. So this SQL query of the data set first of the credit card. After that, I go to the SQL query for high school, and in the high school where I write select age, so I write select age as age M. So I'm renaming age as age M for masters and age HS for high school. Why it is important, why we are renaming, so I will talk about that in a little while. So what I do, rest the SQL query is the same. So select age comma limit balance was there. So what I'm saying doing is I'm writing select age as age M and limit balance as LBM. So limit balance for masters. Similarly, age HS for high school and LBHS for limit balance high school. So we do that. Once we have done that, then I type in this search column as add column. So I drag the add column below. Now this data is for high school, this data is for masters, where the column names have been changed from age to age HS, and this is age M. So we know this age is for HS, this age is for M. So when we add columns, what is happening here? It is adding the two ages as well as the LBM. So one record that I get is I get age HS, age M, and then LBM, and then LBHS. So I get that. So if I don't rename them, so it will be age and age. I don't know this age is for masters or for high school. So that is what we need to do here. That is why we rename. So when we say add column, I do that. So all this is coming as one data set with four columns. Here two columns, here two columns. So here I get four columns. So once I have done that, what is the next thing I need to do is I type in here hypothesis and I bring test hypothesis using t-test below the add columns, which we have been doing even for simple hypothesis. Once I have done that, Then what I do is I go to t-test type and I make it as unpaired samples. So t-test type, if you look at the third diagram, the first value is unpaired samples. So these are not paired, these are unpaired because the values, the number of records, they are different in HS and different in masters. We talked about paired and unpaired. Then we don't use this assume equal variances because the variances are different for masters, different for HS. So I don't assume that. So I don't take here. And then you have to give the value for your mu1 or mu2. In this case, we'll give for mu2 because what we want to prove, that is the mu2, and I put here 75,000. So that is what I need to look at. And then it says select columns. I pick the two columns as LBHS, which is a limit balance for high school, and LBM, which is limit balance for masters. As I have changed the names, so these are the new column names that I've put. So once I have done that, then I give the hypothesis type, which is one tail LT, and then I give the significance level, which is 0.05, which is 5%. After doing this, I run it. You can check all the values here once again if you are doing hands-on. So unpaired samples, and then this is not to be checked, that is assume equal variances. I give the value mu2 75,000. I pick LBHS and LBM, and I pick one tail LT and then 0.05. Once I've done that, I go to test hypothesis box. I right click on that and I say visualize. Once I visualize the p-value, I get the p-value as 0. Then I look at the hypothesis and it says true. That means I have to reject the null hypothesis. In this case, it is what I'm saying is that what I am presuming is true. That is what we want to prove. Why? Because the p-value is 0, which is less than 0.05. So we keep, we reject the null value as in the earlier cases we have been doing. So what we are proving, trying to prove is right. Okay. If the p-value is less than, so we used to say reject the null value, null hypothesis, or the null value. So in this case, we don't have null. So this is what we are going to prove. So if it is more than the significant value, then this becomes false and it will be less than 75,000. So that is all for this. If you have questions and if you would like to do the hands-on, we can do that in Azure ML and you can ask the questions. Otherwise, what we discussed today was purely on Azure ML. We took the example for one tail LT and for the credit card age example, and then we did the A/B testing where we said that the limit balance for masters is greater than 75,000. So we proved it was not statistical noise, but that is true. So once we have done, as you know, there is a small quiz. Today there will be two quizzes. One is a small one. So first question is where you put the value for A/B testing in either mu1 or mu2. Question number 2, why you have to rename the columns when you use add columns in Azure ML. And third is which condition you used in A/B testing example, one tail LT or one tail GT. The answers you can check after you have written. Where you put the value for A/B testing in mu2. Why you have to rename? Because we would like to differentiate between the limit balance of high school and limit balance of masters, which we are going to use later on. So which condition you used in A/B testing example? We used one tail LT. So that is all for this unit and the last lesson. So you have any questions, you can write to me. If you want to go for some further reading, these are two very good. One is a blog, the other one is a course which you can do if you want to go into the depth of machine learning. So that is by Udemy. The first one is a blog which talks about Azure machine learning, and you can do a course from there if you want. Okay, so we are finished with Unit 3, and we discussed in Unit 3, as you remember, advertising and sales promotion, social media analysis, descriptive analytics, diagnostic analytics, predictive analytics, prescriptive analytics, and then we worked on the examples where I gave some exercises. So that was the case study as a lesson 7. Now, here is match the columns. What you need to do is, so on the right hand side in Unit 3 takeaway, I put some of the takeaways which are not matching with the Unit 3 lessons. So what you need to do is you have to match the columns, like for advertising and sales promotion, out of the 7 options, which is the takeaway from there. So you match it, write your answers, and then we'll have the correct answers which you can check. I give you some time. Your time starts now. Well, friends, I think you have written your answers. Please match the correct answers. So, for advertising and sales promotion, it is lift and learn. That is the takeaway we picked. Social media analysis, vanity and actionable metrics. So, we talked in detail about that. So, that is what the takeaway is for lesson 2. Lesson 3, descriptive analytics. We talked about the normal curve, normal distribution, and the probability can be represented by that normal distribution curve, and we call that as a probability density function. Diagnostic analytics, we talked about the statistical noise, and that is why we go for diagnostic analytics. Predictive analytics, we talked in detail about machine learning, and we took that split with 70-30% data, where we trained the model at the 70% data and then used it on the 30% data. Prescriptive analytics, we talked about a lot of things, but optimization and simulation are the takeaways from that. We also talked about strategy and AI in general, and also NLP, natural language processing, how that is becoming popular. We didn't do any hands-on because it's a huge topic in itself. And then for case study lesson 7, we worked on Azure ML to complete all the exercises which were given to you as homework for some of the lessons. So thank you very much, and thanks for being so patient. And I don't believe it, we have done 3 units in such a short period, and it is all because of your efforts. You have been working hard, and I wish you all the very best. And this unit was very important because it was basically hands-on from lesson 3, and we were trying to do all the exercises in Azure ML. So we'll start with unit 4 when I come next time to talk about lesson 1. So thank you very much. Bye for now. Shabbat.